And now we will consider examples. So I'd like to recall an exact differential equation. Is the equation of the type p of xy dx plus q of xy dy equals 0. And this equation is exact if and only if. So first we should check. Just this will be the plan. Let it be here. I will rewrite. Sorry. P of xy dx plus q of xy dy equals 0. We must first check that this equation is exact. This is done by verifying that partial derivatives dp over dy equals dq over dx. And step number 2, we will use the formula for our function. It is equal to the integral from from x0 to x of p of xy dx plus the integral from y 0 to y of q of x0y dy, or f of xy equals the integral from y0 to y starting with q. We will get the following formula, which is slightly different from the original one, but sometimes it is more easy. dx. And step number 3, we will write the answer. The answer will be f of xy, which is found on the preceding step, equals c. So where c is an arbitrary constant. Now task number 1. Let's try to solve the following differential equation. Cos y dx minus x sine y, okay, so minus y squared dy equals 0. Right. And so first we will check. So this is the first equation. I will solve it myself, and after this you will try, right? So first, so this is the p. P is equal to, let it be, equals cos y, and q is equal to minus x sine y plus y squared dp over dy equals minus sine y, and dq over dx is also minus sine y. We can see that they are equal. Step number 2, we may use the formula. Okay. So the integral, what are x0 and y0? We may choose them arbitrarily because so our functions p and q are defined in the entire plane, right, for all values of x and y. And sometimes and often it is convenient to choose 0 for x0 and 0 for y. So let it be set x0, y0 to be the origin. And so f of xy will be the integral from 0 to x cos y dx, so plus the integral from 0 to y, okay, And what is the function? What should we write here? We should substitute x0 for x in the function. So it must be q depending on x0 and y. x0 is fixed, right? But x0 is 0, so we should substitute 0 into this function. And we will integrate just y squared. Or maybe in detail it will be minus 0 times sine y plus y squared dy. And so the answer will be, so if we integrate cos y from 0 to x, the answer will be x cos y. And then 0 times sine y is 0. And we integrate y squared, and this will give us y cubed over 3. So this is our function. And step number 3, the answer is x cos y plus y cubed over 3 equals c, the constant. So this is our answer. Okay, instead, if you have forgotten this formula, what shall we do? What shall we do? We know, so the first step is the same, to check if this differential equation is exact or not. So suppose we have checked. Now we will try to find the function instead of step number 2. It will be a little bit longer, right? But if you had forgotten the formula, you would be able to reconstruct the function. Okay, so suppose we know this. Then we are trying to find the function f such that df over dx equals cos y. Then our function f will be, so we should integrate cos y dx. Okay, and this will be x cos y. And plus some function depending on y, because this is done with y fixed. So in this formula y is fixed, y is a constant, and so we should add a constant as usual for the integration, right? If we integrate, we should add the constant, but now our constant should depend on y. Okay, so this is our function. And the second step, we should find the partial derivative of this constant with respect to y. It will be, so just differentiate this. We will get minus x sine y plus r prime of y. And we know that this is equal to q. So and we will solve the equation. So it should be equal to minus x sine y plus y squared. Now we are trying to solve this. We can cancel out similar terms from both parts, and we have the following equation: r prime of y equals y squared, from which we can find that r of y is equal to y cubed third plus the constant. Now c doesn't depend on any variable, right? It is a real constant. It's a constant. And now the answer. So r of y is found, and now our goal is to write a function. F of xy will be x cos y plus r of y, which is equal to y cubed over 3. Okay, and the answer to the differential equation will be x cos y plus y cubed third equals c, so the same. Okay. But here you can see just one formula, and the procedure on the right part of the blackboard, right? It's too long, but maybe a little bit longer, but this restore the process, right? The procedure. Well, there are two ways. Okay, now the next example. Let it be number 2. Minus 2xy plus e2y dx plus y minus x squared plus x e2y dy equals 0. And this will be the initial value problem. So y of 1 equals 0. Right. Who wants to solve? Okay, so follow. Welcome. So this is a chalk. Minus 2x, with respect to x, e2y, so the same. And next, use the formula. Do you remember the formula? And do you need help?
No.
x0, right? 0, 0, It's okay.
I can write the formula.
Right. Okay, you may use this part of the blackboard. You move. If you want, you may move here. dx. And let's put brackets.
If we substitute 0.
just y. Mm-hmm. 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 Next. Mm-hmm. Correct. Mm-hmm. 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 It is very convenient to use the origin as the initial point, because if we substitute 0, then all the terms will be equal to 0. And so this will be the same, right? So x for x. Mm-hmm.
So it's just going to be this.
Right,
Okay,
right.
I'll write it again.
So, right. Not so. Let's cancel out 2. So we need not write it. Y squared, plus e to right. Y squared half. And equals c. Right. Thank you. Put it here. Okay, so task number 3 will be here. Okay, so very long expression, x cubed plus xy squared sine 2x plus y squared sine squared x dx and 2x plus 2xy sine squared x dy equals 0. Okay, next. Kathy, it's your turn. Okay, this is the chalk. Take the chalk. Right. Mm-hmm. 2y is a constant, so I see. Correct. Now let's compare.
Yes.
Right. So this is the formula for the sine 2x. Double angle.
So I can integrate.
Right, integrate. And then, so you should decide which formula to use. Which formula is more convenient. The first formula, you should integrate this with respect to x.
And this is
or instead you may start with this formula, integrate this with respect to y,
I'll use
and
this.
then substitute y equals 0, right? So I think in this case it's more convenient to start with this formula, right? So if we take x0, y0 to be 0, 0, right, then it's more convenient to start with that formula. Mm-hmm. 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 Right.
Okay.
Mm-hmm. Then differentiate this.
Yes,
Mm-hmm.
so what
And
I will do is differentiate and compare.
right, differentiate this and equate to this expression. Mm-hmm.
So,
You may use this part of the blackboard, so it's empty.
oh no, it is very big.
Okay, so you may, I think it's more convenient to eliminate 2.
Yeah.
It would be more convenient.
Y squared, and in the brackets I have.
Mm-hmm.
Now let me
Mm-hmm.
compare.
And compare with this.
Yeah.
This one. This one. Mm-hmm.
So,
Mm-hmm. Mm-hmm. You may eliminate similar terms, same terms.
always similar.
We might cancel out this. Right.
And
Mm-hmm.
so and
Correct.
okay, so I have the solution, which is
Mm-hmm. Okay, so this is f. Look here, f is equal to x sine squared x times y squared plus r, and it is found.
so
Mm-hmm. Mm-hmm. Equals c. Mm-hmm. Mm-hmm. Thank you. Mm-hmm. Okay, thank you. And if you knew the formula, so you may choose the second formula. And if you knew the formula, you would you would obtain the solution. So in just one integration, f of xy using the second formula is equal to the integral from 0 to y of 2xy sine squared x dy plus the integral from 0 to x, and so we must substitute 0 for y in this long expression. If y is 0, then so the third and the second and the third terms will be eliminated, and we have just x cubed, right? So plus the integral of x cubed dx. So this is a very simple formula, and it will easily give the answer. First, if we integrate this, we will get xy squared sine squared x, and plus x to 4 over 4. And so this is plus c. This is our function, and the answer is given there. Okay, just using the formula, but the second formula, not the first one, because the expression for p is more complicated than the expression for q. And so it is more convenient to start with the q, which is more simple. So instead, we may integrate the first part, and then so if we use the first formula, it would be more complicated.
If we don't choose the origin for x0 and y0, we get the
right. X0, y0 is very convenient also.
Yeah. So let's assume we put 1, 1. Are we going to get
1, 1, but it would be more complicated, of course.
Yes, but would that give us a particular solution?
No, so not a particular solution. So C will be different, but the answer will be the same. Would be the same.
We could have some constant terms not depending on x or y.
Right, but so it will be, if we start with 1, for example, then we need to subtract something. We subtract, and after this we will get the formula. Of course, the formula should be the same. So the formula, the answer must not depend on the way. If if you chose more complicated way, it would be maybe more complicated formula, but the formula would be simplified to this one, right? You may try if you want, but I don't want. Right. So is it clear? Is the method is clear? Okay, shall we exercise with this method more, or maybe we may consider the integrating factor? So the second case is when what shall we do when this equation is not exact? So on completing the first step, suppose we obtain that these partial derivatives do not coincide. What shall we do then? There is a theory of integrating factor. So are you ready for this theory, or do you need more exercises on this topic? What about you? So what about students that are online? Ashish and Krutika, is it enough, or shall we consider more examples on this method, or shall we consider the new method, so the integrating factor? How improve our differential equation in order that it be exact? What is your opinion? It's enough, right? Thank you, Ashish. Now let's discuss integrating factor. So the method of integrating factor. Okay. Okay, so we suppose that our equation is not exact. Suppose that is not exact. Okay, I mean that partial derivatives do not coincide, are not the same. So we may use the method of integrating factor to solve this equation. We may try to use this method. First of all, let's give a definition of an integrating factor. So a multiplying factor which will convert an inexact. So this means that is not exact, inexact. Which will convert an inexact differential equation to an exact one is called an integrating factor. So we will start the exercises with the tasks when we will guess them. So we will find them by guess. So I know the answer, I will show how it works, and then I will describe the methods how it is possible to find these integrating factors. Okay, so example number 1. So we start with the differential equation y squared plus y dx minus x dy equals 0. Let's check whether it is exact or not. So this is p and this is q, and dp over dy equals 2y plus 1, but dq over dx equals -1. So if we compare these two expressions, so they are not equal, so our differential equation is not exact, it is inexact. But I know the integrating factor. Now let's multiply this differential equation by 1 over y squared. Multiply by this coefficient. And this is an integrating factor. I claim that this is an integrating factor. Let's call it h of y. Is an integrating factor. So let's prove this. If we multiply both parts by this factor, we will get the differential equation, the new differential equation. It will be this 1 plus 1 over y dx minus x over y squared dy equals 0. So compare the original differential equation and this one, right? So the same. So the these two equations describe the same function. Just so the new differential equation is obtained from the original one by multiplying by 1 over y squared, right? But now this differential equation is exact. Let's check this. So it is exact because dp over dy equals minus 1 over y squared, and dq over dx is also minus 1 over y squared. So they are the same. Right. And so we can solve it. Let's do this. X0, y0 will be, so y cannot be 0. So I will choose the point to be 0 and 1. Let it be 0 and 1. And then our function f of xy will be the integral from 0 to x of 1 plus 1 over y dx plus the integral from 1 to y. So I must substitute 0 for x, so 0 dy. It is equal to x plus x over y plus c, and the answer will be x plus x over y equals c, where y is not equal to 0. And a particular solution will be y equals 0. Right? This formula gives a particular solution for our equation, because we have divided by y squared, so we have lost a solution. So this is a particular solution. This is this solution is given for y which is not 0, and this is a particular solution. Right. So this integrating factor is found by guess, because I know I knew the answer. But now how can we proceed if we don't know the answer in advance?
This equation is variable separation.
This one, right. So the variables are separated, and so we may use another method to solve it. But sometimes it is not separated. Then what shall we do in this case? How to how to find the integrating factor? So there is no a general method for doing this. Several methods are devised but they work only for specific types of differential equations. They are not general. So the most simple of this these are the cases when the integrating factor depends only on one variable, on x or on y. And now I will show you how to find this integrating factor, and how to check if it is possible to find the integrating factor depending only on one variable, and then how to complete the solution of this equation. Okay, so I will use that part of the blackboard. Okay, so given this equation, which is inexact, suppose this equation is inexact. Let's try to choose an integrating factor depending only on one variable, say x. H, suppose h is an integrating factor and it depends only on x. Then we will try to find the formula for h of x, and and we will answer the question if it exists or not. How to check quickly if it is possible to find this to find the function depending only on x or not. So it can be done. Right. So suppose this is an integrating factor. Then let's multiply this equation by h of x. Suppose this differential equation is exact. These are new functions. This is p new, let it be pn, new function p, and this is new function q. If this differential exact, then partial derivative of this new coefficient with respect to y must be the same as the partial derivative of this coefficient with respect to x. Let's differentiate. Let's find it. D over dy of h of x times p must be equal to d over dx of h of x times q. So p and q depend on x and y, on both x and y, but h depends only on x. Let's find the partial derivatives in both sides. Let's differentiate. So the partial derivative of this expression with respect to y first. But h doesn't depend on y. So this is the constant, just a constant, h of x times dp over dy. Right? It must be equal to, so let's differentiate this expression. So this is the derivative of the product. The derivative of h will be h prime with respect to x, of course, right? Times q plus h of x dq over dx. And now h of x can be found from this equation. This is a differential equation. P and q are known functions. And now we have a differential equation to which determines h, right? So h prime, and h, this is a linear first-order differential equation from which we can find h. Let's show how it can be done. Well, let's rewrite our equation as h of x times dp over dy minus dq over dx equals h prime of x times q. Right? So I have moved this term to the left, right? And our equation has become this. Now, is it clear? Okay, right. Now, how to find, the question is how to find h. So now the variables can be separated, right? So h and h here. We have the following. So just change the side. So it will be dh over dx times q equals h times dp over dy minus dq over dx. And then dh, we separate the variables. It will be dp over dy minus dq over dx times dx over q. Now, is it clear? And after this, we will integrate both parts. And then we have the following. So the logarithm of the absolute value of h equals the integral. So maybe it's more convenient to denote this complicated function by f. Let f be equal to dp over dy minus dq over dx over q. So let it be f, and so this is equal to the integral of f of x dx in our notation, from which we can find that h of x is equal to, so we need to know only one particular function, not a general solution to this equation. We need only one function for the integrating variable or integrating factor, right? So h of x will be equal to e raised to the power the integral of f of x dx, without any constant, only a particular function. Okay, so this is h of x. And if this integrating factor exists, then it is equal to, it can be found using this formula. But how can we decide, is it exist? So does it exist or not? So this function, depending on only on one variable. Okay, the answer is, first we need to compute this function, this expression. And if this expression depends only on one variable x, then it is possible to find the function f of x. Look here, f must depends only on one variable x. Sometimes this expression depends on two variables. Then we can't use this method, we can't find an integrating factor, right? So on the first step, we should check whether this function depends only on one variable, and then after this, by integrating, we will find the integrating factor, and after this, we may proceed the same way. So perform the procedure for finding the solution of an exact equation. Right, so multiply by this integrating factor and solve the exact differential equation. Okay, now I will show how it works.
You can also find f of y by dividing by p instead of q.
Right, so dp over dy and dq over dx are found on the first step, right? Because when we check that this equation is not exact, so we have already found dp over dy and dq over dx. And then if we find the difference of these two partial derivatives, so next we find the difference and divide by q. And if this doesn't depend on y, then we are done. Then it works.
Oh, I'm saying that if we had written h is equal to h of y instead of
right, so then we should switch these two terms, right, and divide by p. Of course, yes. And we will use the same method for h of y. Let's try to use it. Just a moment, I will find them. Okay, that will be task number 4. E to x minus sine y dx plus cos y dy equals 0. Okay, so first let's check whether it is exact or not. So p of xy is e to x minus sine y, and q of xy is cos y. Then dp over dy is minus cos y, and dq over dx is 0. Okay, so it is not exact, right? Then we may try to find the integrating factor. So if this difference, so we should consider the difference minus dq over dx is equal to minus cos y. Okay, so for the integrating, this is for the integrating factor h of x, and if h depends on y only, we will get the function g, let's call it g of y, and it will be dq over dx minus dp over dy divided by p. And so to decide between these two cases, so if we compare these two expressions, we can see that numerators are the same, just they are different in sign, only in sign, right? But here we divide by q and here by p, right? So for example, so this is the so now in our example, this is the difference. If we divide by p, we can see that we can't avoid x. So the ratio this divided by p of x will depend on x. But if we divide by q, we can see that y will be eliminated, right? So now if we consider this expression minus dq over dx divided by q, we will get the following: minus cos y divided by cos y, which is minus 1, negative 1. So we can see that the resulting function doesn't depend on y. So this can be taken more exactly, so this can be taken as the integrating factor. So let it be f of x, and then the integrating factor h of x will be e raised to the integral minus 1 dx, which is e to negative x. Right. So this is an integrating factor. It is found. So the procedure is to find the difference and then to try to divide this difference by p or by q and decide between these two situations, right? But if both formulas do not work, then the situation is more complicated, and so it should be solved by other methods maybe. But now, so we will discuss the first type, this one, right? H of x is this function, and then let's complete the solution of our task. So we are asked to find the solution to this differential equation. So this is the first step. This is, I think this is the second step, finding the integrating factor. Next, step number 3, we should multiply by this integrating factor, and we will get what? The new equation will be 1 minus e to negative x times sine y dx e to negative x times cos y dy equals 0. This is our new equation, right? And now this is a new function p, this is a function q. Then now dp over dy, let's check whether it is exact or not. Dp over dy will be minus e to minus x cos y, and dq over dx will be minus e to negative x cos y, so the same. So magic. So now it is exact. Okay, and after all, we should find the function by integrating this function p. So we may choose x0, y0 to be 0, 0. And so we will integrate from 0 to x 1 minus e to minus x sine y dx plus the integral from 0 to y. We will substitute 0 here, we will get, so just cos y dy. And we will get the following. So x plus e to negative x sine y, and we must substitute substitute the limits of integration now, right? Because so if x is 0, then it is not 0, right? So we must substitute limits. Next, minus the integral of cos is, so plus sine y from 0 to y. And this will give us x plus e to negative x sine y minus sine y and plus sine y. Okay, they are eliminated, and so the answer is f of xy is x plus e to negative x sine y. I hope it's correct. And number 5, the last step is to write the answer. The answer is x plus e to negative x sine y equals the constant c. Okay, what about the break? So I think it's too late for the break, right? So 20 minutes left, or just a moment, right? Do you need a break or not? So maybe we will finish. Right. So let's try to solve just maybe 2 problems, and after this we will finish. So is it clear? All right. Now this task number 5, I think it's 5. The equation will be xy dx 1 plus x squared dy equals 0. Okay. Who wants to solve this? Your turn. Welcome. This is a chalk.
So easy by variable separation.
Variable separated, yes. It is variable separated. But let's try this method of finding integrating factors. You should be able to use several methods. So there should be many methods at your disposal to be able to solve any differential equation. Mm-hmm. Mm-hmm. Okay. Right. Now we will try to find the difference and try to divide by P or by Q. Right?
I think I'll go with the x of y, maybe.
P, right. So the difference will be x or minus x, and if we divide by this, we will
We get a function.
eliminate. Right.
With y.
So the second. So h will depend only on y. dq over the x minus. So first you should start with this formula g of y, and after this h of y will be e raised to the power g of y dy. So first find this complicated function, after this integrate it and use this formula.
Yeah.
Right. Well. It's y. Right. So the integrating factor will be y. Next, rewrite this equation multiplied by y. Correct.
I'll check.
No, you may check. So you may do it in mind. Let's do it. So if we differentiate with respect to y, we will get 2xy.
Yeah.
And then after differentiating with respect to x,
2xy.
right, so 2xy, right. So they are equal.
Yeah. So we can write down the function.
So I recommend to check this because so to avoid mistakes on the first step, right? Maybe you are wrong in computing. You were wrong in computing the integral, or so in some manipulations. So this will check your result, your first step. Okay. Now, so solve this.
Yeah, we can write the function as the sum of
You may use the formula. So f of xy equals. So it is not now. Yeah. So you may use. Right. I will help you if you need.
We can use the formula where.
So integrate the first with respect to x.
I'll write it like. Sorry, not but so.
What would you prefer, the formula or the method?
I'm just gonna write it again. For my own.
Right. So the first step, of course, is to integrate this. So the integral dx. So just integrate this first type, and then plus the constant, which depends on y.
We can use 0, 0, right?
Y squared. 0, 0, 0, right? You may use this. But you should put square.
If we plug in x equals 0.
Right. You should integrate y. Y dy. From 0 to y dy. Right?
Dx y squared.
So not differentiate but integrate. X dx. Do not confuse integration and differentiation.
Integrate x y squared.
X squared, of course, yes. Now over 2.
Plus y squared over 2.
Correct. This is f, and then so the answer. You should equate this, set this equal to 0.
To C, right?
C, maybe. You may use the letter C. And you may eliminate 2 if you want. So equals C, of course, equals the constant. But if you don't want to divide by 2, you may write this in the form, So you may write the answer in the form, thank you. Y squared x plus 1 equals C. You need not multiply C by 2 because it's an arbitrary constant. So this is the answer, and you may check, let's check that it satisfies the original equation. So if we differentiate with if we find the total differential of this, we will get x squared. Right? Okay, I think yes. Right. And what about, okay, well, shall we solve the last equation or shall we stop here? It's up to you. We have 10 minutes left. Or says 13 minutes left. Do you want to solve one more equation? So the last one. Okay, so minus 2 once, okay, once follow, your turn.
Why did I judge you?
And,
First.
okay, so we need partial derivatives for the second step when we will try to find the integrating factor. We will need these partial derivatives, so y squared, right. They are not the same. Right, and after this, let's try to divide by, so we should try to divide by P or by Q. Choose. So, so in these formulas, we must divide by Q or by P, and so
I'm trying to decide.
right. I think so. I can't see 3, the factor of 3, but if we compare with this 1 and 2, and here 2 and 4, I think it can be divided. They can be divided,
So let me
right?
write this.
2, right, x minus, right, 2y, and try to divide by p, I think.
Okay, so by p that would be, so I'm just going to, since we want to use
So you should change the sign, right?
y squared.
X minus 2y, right.
Okay, great.
Next, use this. So the formula for h of y. So first integrate this with respect to y. So the integral of this function, right? dy, 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 right? Minus 2. And then h of y would be, so h of y now. So we'll write it here. H of y will be, so e raised to the power minus 2 ln y, absolute value of y, right? Right. It's correct. Y no y squared, right?
So
Let's multiply our equation by this factor. Correct. So I think integrate this, and after this, x0, y0 would be, so let it be 0 and 1, I think, because we can't divide by 0. So 0 and 1, I think it's okay. Right.
I will substitute 0. 3 over y squared.
Right. X squared half, right? Minus, minus, so raised to the power -1, right? Y to -1, 3 over y, maybe.
Oh, I forgot.
Just, I think it would be a constant. So if you subtract the, so if you substitute limits, right? And you need to subtract, so add 3, but I think we need not do this because it's a constant, and it will go to the answer, right? Equals C. Thank you. Correct. Thank you. Okay, so now we will stop here. See you later. See you next week. Bye.